I want to start a series of videos on books that every mathematician should have looked at or read at some point in their lives. And of course, I want to start with Euclid's Elements. This book is just amazing. It's amazing from a historical point of view because it was written some 2,300 years ago, and it was used as a text to learn geometry for over 2,000 years. Well into the 1800s, people still read Euclid as a textbook in geometry. President Lincoln learned geometry from Euclid's textbook. Nowadays, it's not mandatory reading, but students in high school are still learning geometric proofs that are in Euclid's books. And some mathematicians say that everyone should read Euclid. I don't think so. I think it is very interesting from a historical point of view. It's very interesting to read some of the propositions and read some of the proofs to get a sense of how somebody over 2,000 years ago thought about mathematics. But I don't think it's necessarily a book you should read, definitely not from cover to cover. Euclid's Elements is not just one book, it's in fact 13 books on geometry. And by the way, if you pick up this edition of the Elements, the commentary by Heath is really interesting and wonderful. And as I said, everything about this book is just really interesting. For example, the very first definitions in the book. A point is that which has no part. A line is breadthless length. A straight line is a line which lies evenly with the points on itself. And then after those very interesting definitions come what Euclid called postulates, or that we would call now axioms. And then, of course, there is the fifth postulate, which is the postulate or axiom that two straight lines either intersect or they are parallel and they never touch, which of course has a long and rich history that starts with Euclid and finishes with the discovery of non-Euclidean geometry and things like Riemannian geometry in the 1800s. Just this one paragraph, it's such an iconic part of mathematical history that is just fascinating to even read how Euclid expresses this concept. And again, if you have this edition of the book, Heath's commentary on the fifth postulate is fantastic. The book is full of cool little interesting results in geometry, and even the most basic ones, proposition 1 in book 1, it is just really interesting, to me at least, to read such a proof and see how someone like Euclid in 300 BC organized a proof. And of course, my own personal favorite is proposition 20 in book 9, where Euclid proves the infinitude of the primes. And it is interesting that this proof in particular is an example of how some of the proofs in the Elements do not have the generality that we expect from a modern proof. For example, in this proof, he shows that if there were 3 primes, there would be a 4th prime. And it doesn't show that if there were n primes, there would have to be an n plus 1th prime, as we would expect in a modern proof. So what he does is show the theorem in a case that is general enough that you can see how this would carry over to any number of primes, but he doesn't have the terminology or the techniques to show this in general.